Hello everyone, welcome to EDCON 2020 and here is Jacky from Unitimes and today I'm gonna give you a presentation about promote technological innovation from the community. So, in the past 20 years, the internet has realized the connection between people, broke the information silos, and also pushed the explosive growth of information. Actually, we've witnessed the development of the internet from PC internet to the mobile internet, which runs through the content evolution from portals to search engines, and then to social network, and to now the vertical application diversion. We have also witnessed the birth of the giant at every stage of the development of the internet. Despite the monopoly growth of the giants, they're recutting the internet traffic into larger information silos. Actually, on the other hand, in the past 10 years, the giant has also promoted open source culture with their own financial and technical power. So, in generally, the development of technology and communities has created the prosperity of many newly and innovative technologies such as cloud computing, a big data, and autopilot. So, this question that we want to ask: why is the giant so keen on open source, and they even put open source at an incredibly important high? I think because with the development of cutting edge technology, the interactions of technology, logic, and user experience has become more and more complicated. Actually, open source to a huge developer community will allow more people from different industries and different backgrounds to contact and identify vulnerabilities in code and even products from different angles, thereby reducing the trial and error costs and increasing innovation. But there are still some problems with this model. For example, one of the most significant drawbacks of this model is the drying effect. The drying effect means that it may confuse the importance of small teams and individual developers, thus decreasing the enthusiasm of a considerable number of technological participants, and at the same time, making many valuable but not high-tech ideas to be ignored. Well, essentially, the giant's open source behavior mainly aims to ultimately feedback their own development, so there will still be many restrictions on specific open source implementation strategies. Well, the birth of the blockchain technology has made decentralization, open source, and community deeply rooted into the mind of the people, especially developers. Actually, there's something enlightened us is the success of Ethereum is not only the success of Ethereum itself. It is not only the success of blockchain technology too, but also it is a success of the idea of communitization and decentralization of innovative technologies. Ethereum shows us that we have seen the we have seen that the innovation and cohesion of a huge technical community formed by most individual developers and small teams is not inferior to those high-tech clubs formed by giants. Actually, so it is foreseeable that in the near future, the concept about communitization and decentralization become more and more common, and they even will become the mainstream or the main trend leading the development of technology. So, what can we do to face the trend of communitizations? First of all, we should improve infrastructure. Which means we should provide complete platform services for the majority of technology companies, teams, individual developers. Um, Actually, in the past 5 years, there's the very popular PaaS, which is used to refer to the business model of cloud computing platform. Actually, in the next 5 years, I think PaaS can not only be used to refer to the uh, cloud computing platform, but also to be used to refer to the business model represented by community platform. And so, considering its next stage, um, I think to building a community platform will be is not that easier, or it is even much more complicated than building a cloud computing platform, because for a community platform, its prosperity depends on the platform ecosystem, which means it depends on the prosperity of the community, while the prosperity of the community depends on the community ecosystem. It's too complicated. So building a community platform will bring unprecedented challenges to enterprises and put forward higher requirements for enterprise products and operations. Well, the second things we should do is to keep open-minded. Actually, we should be more open-minded. The era of internet monopoly is not over yet, but it is about to pass. So in the future, as a community platform, we should push community integration, step out of its own platform limitations, and realize cross-platform community and interaction with the outside world. Well, we foresee that in the future, technology enterprises will continue to decentralize or open source a large number of non-core and more core technologies to the community, organically guide community to development, and derive the mature results to feedback themselves. Also, I think small teams and individual developers can be able to build specialized communities based on their own crazy or innovative ideas, to develop a personalized community ecosystem. So on the whole, in the future, the giants will still control the top, while the small teams and individual developers will keep cultivating in the sinking market, and those two cooperate with each other will push the development of technology and also the technical innovations. Well, so what Unitimes has done in the past 3 years? In the past 3 years, Unitimes has been focusing on the deep cultivation and development of the blockchain community. In the next 3 years, Unitimes will focus on providing community services for enterprises, teams, and individual developers in innovative technology fields, including blockchain, cloud computing, Internet of Things, and artificial intelligence, and so on. In the just concluded GroupCon 2020 hosted by CNCF, and Unitimes participated as the community partner for the first time, and in the future, we will continue to expand cooperation with open source projects, organizations, and enterprises at home and abroad, unremittingly promote the construction and development of open source culture, and provide developers with the best community infrastructure. So, this is the end. But before that, I still want to say one more word. I just want to say the future is coming. It is not in somewhere, but in our hands. So in this happy ending, so let us toast to Ethereum, to community, and to technology, to whatever, and to our future. So that's all. Thank you.
Hello everyone, EDCON. I'm Adelyn Zhou. I'm super excited to be here today with you all to share with you how smart contract oracles are unlocking the value of the DeFi revolution. So first, we're all in this industry because we're excited about how the blockchain will revolutionize supply chains, insurance, finance, and countless other services. However, there's a fundamental challenge for blockchains to fully fulfill this vision. The blockchain is an isolated database, and it's separate and unaware of what is happening in the real world, the world that you and I live in. The blockchain cannot communicate directly with the real off-chain world, and this is what we call the oracle problem. Blockchains gain their security from a distributed network of independent miners or node operators. And the blockchain's decentralized nature, though, prevents it from directly accessing off-chain information. Real-world information, such as financial market data from Bloomberg or the New York Stock Exchange, or event data from IoT devices or GPS locations, cannot be fed into the blockchain. Similarly, decisions made by smart contracts on the blockchain cannot be communicated off-chain to trigger payments and other actions. What we're missing is a communication layer between the on-chain and off-chain world. Because of this missing on-chain off-chain bridge, the majority of historical smart contract use has centered around tokenization. This is because issuing and tracking changes in token ownership is contained to on-chain movements. For example, if you gave me 1 Bitcoin, all that information of you handing that Bitcoin to me is tracked on the Bitcoin blockchain. However, the data around token transfer is all kept on-chain. Yet, tokenization is only one really small percent of smart contracts, or what their possibilities can be. Cut. Yet the true power of smart contracts is when we integrate them into existing legacy systems and infrastructure. It's when we connect these contracts to the real world that we build universally connected smart contracts. That's when we really see the power of smart contracts to change the world. We're all witnessing the recent meteoric rise in decentralized finance, otherwise known as DeFi. In just the last few months, we've seen the value locked in DeFi soar to almost $4 billion. Unlike traditional, tokenization, DeFi applications need to connect to off-chain data. They need to understand the price of an asset from multiple data sources, including both on-chain DEXs and off-chain centralized exchanges. We at Chainlink are working with many of the top DeFi projects, including Synthetics, Aave, Nexus Mutual, and many others, to provide them with this price data. For example, Aave, a popular borrowing and lending platform, needs to know the price of ETH to USD to calculate the collateralization rates on their loans. That ETH to USD rate is off-chain. In our previous tokenized environments, you only needed one part of the contract, the token generation contract. All that information to track token movement is on-chain. There was no need for external data. But now, with DeFi products and all the other blockchain use cases that we all want to see realized, your smart contract has a new part, an off-chain part. This off-chain part encompasses external data, enterprise systems, traditional payments methods, and so much more. In order to provide the same trustless securities that will guaranteed by the blockchain, which is why you want a smart contract to begin with, you need to have end-to-end reliability within your entire smart contract system. What we do at Chainlink is provide the secure and reliable mechanism to bring data on-chain as well as off-chain. This requires a number of new approaches through something called an oracle. We focus on creating a decentralized oracle system that validates inputs, provides access to payment outputs and connects to various existing infrastructure and systems. We enable smart contracts, regardless of what chain they're on, to get all the inputs and outputs they need. So let's talk about how we approach this in creating secure oracles for Web3. First, we do this through decentralization. We have countless independent, Sybil-resistant nodes in our oracle network. Similar to the blockchain, decentralization is at the core. Next, these nodes provide security through various cryptographic systems. In addition to having the top industry node operators, we also have enterprise node operators. We recently welcomed Deutsche Telekom, one of the world's largest telecommunications providers, as a node operator to the Chainlink ecosystem. High-quality data is another key component. As the saying goes, garbage in, garbage out. Thus, our Oracle system focuses on connecting smart contracts with high-quality credentialed data. We also provide crypto-economic security guarantees based on staking to ensure that node operators behave honestly and reliably. Then we couple all of this with defense in depth practices. We layer on trusted execution environments, zero-knowledge proofs, and other secure approaches to ensure that the Oracle system is secure. And finally, all this is supported by a large open source community of trusted developers, node operators, academic researchers, and security auditors. We are proudly built on Ethereum and have been working with the top Ethereum DeFi applications. Ethereum is where we have the largest variety of data products available today. We also make Chainlink oracles available across all types of chains. We do this because by supporting more chains, we grow the overall demand for off-chain data. And when you have more demand for data, that becomes a greater market opportunity for data providers. This incentivizes data providers to provide more data into the blockchain ecosystem overall. And this benefits everybody. It's a win-win situation because now developers and smart contract creators can have access to more high-quality data. The Oracle problem is how to bring data into a blockchain, right? We talked about that. However, just as decentralization is important to the blockchain, decentralization is also critical to the Oracle mechanism. That's why it was the number one point that I mentioned earlier. In this example you see here, a centralized Oracle becomes one node and is a single point of failure. Even if your smart contract is built on a decentralized blockchain, using just a single oracle centralizes your entire smart contract. It puts your entire smart contract at risk. Your smart contract is only as secure as its weakest link, and if it's a centralized oracle, then that becomes the weakest link. So just as your blockchain that your smart contract is built on is decentralized, your oracle system needs to be as well. We address the decentralization challenge by having fully independent Sybil-resistant nodes. We focus significantly on the quality of the node operators. And we also make node networks of no fewer than 7 nodes. Our typical networks have many more nodes, some as many as 30 or more. As a user, you also have the ability to see the quality of these node operators, which make that information extremely transparent, and all the data that's generated is open and visible on-chain. It's something that anyone can analyze, so we're very transparent about that. Some of our awesome community members also created the website called reputation.link, and it features a tons of great charts and graphs that allow you to review node performance history. You can compare them against a variety of metrics such as transactions, numbers completed, response times, and more. Another super critical part about oracles is data quality. As mentioned, garbage in, garbage out. Even if you have the most centralized oracle system with the best security guarantees, if the data that you're feeding into the system is junk, then you will get garbage coming out as well. So this is a serious problem that people need to understand. and it's one that creates a significant risk for DeFi applications. If the data that you're using is not right and not good, then it's triggering the wrong contracts and triggering things incorrectly. So credential data is a must, like absolute must, for any contract of value. Chainlink was built from day one to access this high quality credential data. And we've baked that ability to access credential paywalls into our original architecture. Many of the other Oracle systems out there do not have this ability to access premium data. Instead, they rely on free, low quality data pulled through complimentary free APIs. But this doesn't work. It's as if you're trying to watch a great movie, but instead you're watching a pirated version that someone filmed on a camcorder in a dark movie theater with heads bopping around, right? That's not the way to watch a good movie, and that's not good quality. Similarly, when you have good quality data, you need that into your Oracle system. And so in our price reference contracts, we only use premium data sources. We don't pull from any single exchange nor any free open APIs. We work with professional, experienced data providers. We also provide a lot of customizability to the user. Here you can see a node job ID that defines a specific work that a node will be providing, as well as the actions it's taking to assure the quality of the data. This level of definition is important because as your contract increases in value, which we hope it does, you will need to prove this to users. Users want to understand how you're triggering their contract. Another thing Oracles need to do to maintain their security and reliability is through the use of service agreements. We use on-chain agreements that define all parameters under which a node will be delivering data to it. As more data and usage flows through the Chainlink system, you'll also gain additional information about the reliability and performance of nodes. In the system of a web of trust, where node operators have a history of performance, you can start understanding how trustworthy a node operator is by its past history. And finally, crypto economic security from staking. So crypto economic guarantees are deposits that the nodes will perform as promised. Link tokens are used to guarantee that the data is properly delivered. And if that data is not delivered under the right conditions that are set in initial contract, then the operators will lose their stake. This is very clear motivation for them to maintain the security of that Chainlink node. Finally, Chainlink is incredibly customizable. We've discussed how you can decentralize the nodes. You can also decentralize at the data source level. You can decide on the number, the type, and the sources of data that you want to pull from. All that is up to you. And with that, this is how Chainlink is able to empower the growth of DeFi. We create that bridge for that off-chain data from exchanges and DEXs to bring that on-chain into your favorite DeFi dApp. And most dApps find it easier to use a pre-built Oracle system like Chainlink rather than build it from scratch. As we mentioned, there's so many components around security, reliability, and research that goes into thinking about how to create a solid, secure Oracle system. And by just using the plug-and-play system of Chainlink, we greatly reduce the amount of time it takes for a DeFi developer to take a dApp to market. And by doing so, we allow them to build faster and build great products for end users. So if you're interested, you can check out some of the feeds live. If you go to feeds.chain.link, there's tons of different price reference contracts that are already out there being used live in production by some of your favorite DeFi dApps. DeFi is just the beginning. We're super excited to see where this industry goes, and we can't wait to see what else we can create with connected smart contracts. Thank you.
Hi everyone, Conor Svensson here, founder of Web3 Labs and author of Web3J. I'm excited today to be giving my presentation all about going from zero to live with Web3J and Epirus. So the fundamental problem that we're trying to address at Web3 Labs is that blockchain development is difficult. It's not easy for people to get started with the technology, and even when they do, to actually get to the point of having something live on a public network is hard. I like to think of it like a funnel, really, like they use a lot in marketing, where at the very top you have the initial decisions that people make, and then as you go further down the funnel, you get to the end goal, which in our case is deploy something on a live network, but for users, there's this huge learning curve that they need to overcome. And in the same way that in sales and marketing, potential customers are engaged, and then at each point, ultimately they're trying to get them over the line, which is to buy a product or a service. It's a similar thing with blockchain and trying to actually get an app live on a network, and all of the learnings that go with that. And so the stages I think of with this anyway are that at the very beginning you've got to select a blockchain, but then you've got to connect or run a node, figure out the wallet funding, the key management side of things, actually develop the smart contract, test and debug it, integrate it with your app, and then finally deploy. It's a lot of steps, and at every single one of those stages, you can see drop off where users don't actually, go any further, which is a real problem for adoption of any technology, and which is what I'm here to talk some more about. Okay, so let's talk about some of these stages, individually. So, when it comes to selecting a blockchain, we're all here at EDCON, so I think we know what blockchain we're looking to select there. So, that's a done deal, so to speak. There's a powerful community here, and I think that's one of the very compelling reasons that got me first into Ethereum, all those years ago. Then when you've actually want to develop your smart contract, you've got some great tools there, such as OpenZeppelin and a number of other libraries that build on top of that. And then you have the actual developer integration library, which I'm going to be talking about Web3J, but there's obviously lots of others out there as well. And those enable you to actually integrate with your application. But then you've got these other pieces, the actual node part of it, the key management, and how you actually go about running the application. And typically, when people want to address these parts, they start to end up with quite fragmented solutions, because you've got some great solutions out there for these individual components, but you don't have anything that really ties it all together nicely. And that's what we address with Epirus. So before we talk about Epirus, I'm going to talk some more about Web3J and all of the work we've been doing recently, because the library's come along a lot in the last 4 years. It started off life as being a straight integration library for Ethereum. So you'd have your Java or Android application, and then you'd have Web3J, which takes care of the JSON RPC calls with the actual Ethereum clients, but also the smart contract piece as well. So the actual library itself, it was first created in 2016. And as I said, it supports all these different JVM languages. So that is primarily Java and Android, but also Kotlin, Scala, Clojure, and so on. You can do things like create wallets, and actually transact with the blockchain. It also takes advantage of the type-safe nature of Java to provide type-safe integration with smart contracts with the EVM native types. And it's got a really good build tool integration with Maven and Gradle, which are the dominant tools used on these platforms. The actual library itself, it's had over 120 contributors, over 500,000 downloads of the core artifacts. If you add up everything, that's over 3.5 million. And it's got coming up to 3,000 GitHub stars. We've got a full-time team on it. And of course, this wouldn't be possible if it weren't for the support we've had from the Ethereum Foundation, the Ethereum Community Fund, and Gitcoin. So thank you very much for everything that you've helped us with over the years. So if we talk about the individual things, though, that Web3J does now, it's a lot more than just an integration library. We now have a Solidity compiler built into it. So if you're using Web3J in your project and you're using our build tools there, then you don't have to install Solidity on your actual build machine. Web3J does that for you with the Solidity Gradle plugin that we've written. So what this does is it looks at all of the smart contracts in your project, looks at what Solidity version they're actually using, and then takes the most recent version of Solidity that's appropriate to compile all of your smart contracts and downloads it and runs it at build time for you. So regardless of whether you're using Windows, Linux, or Mac, it just works out the box. And of course, the output here is your binary and ABI files. This then goes as the input into the actual build plugin for Web3J, which then creates these Java-based smart contract wrappers for your smart contracts, taking full advantage of the JVM's type safety. So this means where we've got, say, a Hello World contract that we've just put on the right here, you can deploy it in Java code or Android Kotlin, whatever else, put in what you want to say there, and you can actually send that, and that transacts with the live network. One of the pieces, though, that we're really happy with that builds on top more of all of this great functionality is the testing as well. So we make it really easy to actually test your smart contracts against multiple blockchain clients, which we think is a really important thing when, especially when you look at the amount of value that can be locked up in smart contracts, and also that we want to ensure that enterprise customers are well catered for here. And so we achieve this through our Web3J units and Web3J EVM projects, which come together. And what we have is a simple annotation that you add to your unit test, which basically says EVM test. And what that gives you is an in-memory production grade EVM. The production grade EVM is the Hyperledger Besu EVM, but it runs in memory against your unit tests. So what you can do is you can have a unit test and say, add in this EVM test annotation, and then we can actually deploy the smart contract. And then we can verify that the greeting we get back from this Hello World example is what we expect it to be. And so this is great because it enables you to actually do all of this testing in memory rather than have to go out to an external system or anything like that. You may see here that there is actually a typo. There's an exclamation mark missing. I wanted to include this so that I could illustrate the next point, which is that if we do have a test that fails, the Web3J EVM will actually pick up where in your Solidity file it failed. So this makes it really, really powerful with regards to unit testing as well, if you're using Web3J, because you can really test your smart contracts properly from within the JVM. The other thing you can do is you can change the actual nodes that you want to run against. So maybe you don't want to use the in-memory EVM, you want to use Geth. So you just type node type of Geth, and what that does is it spins up a Dockerized Geth node for you to run your tests against. Maybe you don't want to use Geth, maybe you want to use something else. How about you want to use VMware's Concord? So here we have a Docker Compose file, which spins up a Concord network, and this will run your tests against it. It really is that simple. And this, again, is some of the powerful orchestration that we have happening behind the scenes, taking advantage of great libraries that already exist on the JVM, like test containers, to help with the Docker integration. The other thing I'm really happy to be talking about is our latest project, which is Web3J Open API. So this takes a Solidity contract and will actually generate a JVM-based Open API service for working with your smart contract. So you don't need to write any code at all beyond the smart contract. So you basically pass that to the Open API generator, and this will spin up a RESTful endpoint for you, which you can do your contract deployments, you can actually transact with the contract and everything else. But again, you don't actually have to write the code there. So it's all ready to go, which we think is very powerful, especially when it comes to common use cases, such as creating an API to work with a smart contract, which we see again and again. I'd love to talk more about this, but unfortunately, we don't have too much time today, and which takes us on to the next part, which is if we look at the funnel, and we're talking that the missing links here though with the whole deployment, key management, and wallet funding, and then actually connecting to a node. And this is where Epirus comes in, and we really feel that this is a very important link in the chain to simplify the experience for users of Ethereum on the JVM platform. Simplicity is at the heart of Epirus. We've made it as simple as possible to do everything that we believe users need to do. So to start with the installation, it's a single line there. So just use the curl and then specify this endpoint, pipe it through to shell, and that will install the CLI locally on your machine. If you're using Windows, it is slightly different, but if you go ahead to our documentation page, you can see it there. Then if you want to create a project, you just type Epirus new and then say, do I want a Java project? Do I want an Open API based project? Or do I actually want to create an ERC 777 token? So again, it spins up all of the foundations they're using, all of the build tooling in order to ensure that you've got a great foundation for actually developing your JVM based project. We're really thinking in terms of this being production grade in terms of how it's set up. We're not talking about just simple projects. It's rock solid stuff. So then if you have some smart contracts that you've already written and maybe you want to bring them in, you can just use the Epirus import command. So you can specify, I want to create a open API project based on these contracts, or maybe I want to actually create a Java project using it. If you're using the Java one, you can also get it to generate unit tests for you as well, which makes it really simple to actually then use the embedded EVM to actually test your contracts properly too. The final piece of the puzzle is how you actually run it. And again, with Epirus here, you can basically do Epirus run with your project and then specify what network you want it to run against, and it just works. There is one caveat here, and of course that's that mainnet isn't quite ready yet, but we are live now on Rinkley and Roxton. And also too, if you want to build a Docker image and to run the Docker image instead, you just type Epirus docker run. And so really these commands, the install and then the create project and then the run, Epirus takes care of all of this for you. And this again is why I'm so excited to be talking about it today. Of course, how we actually achieve this, the running is an important consideration. You do need to have an account with Epirus to achieve this. And that's so that we can do a few additional things. So we can, when you actually run the project, if you don't have a wallet, then we create the wallet, and then we also fund that wallet for you, and we fund that wallet on an ongoing basis as well as you transact with the network, so you don't have to think about your transaction fees. We also provide the network connectivity there as well. Behind the scenes, it's going out to one of the well-known providers there. And two, we provide the gas pricing infrastructure as well, so that you won't have to think about that. So you can focus on just actually developing the application. The Epirus portal itself gives you a bit of information about everything that you've been doing. So the contracts you've deployed, the wallets you've been using, the actual JSON RPC logs. Again, very valuable information, because we believe that most people actually want to, remember what they've actually done on the network. It's really easy to lose track of this stuff. And then that's also supported by our Epirus Explorer as well, which is a block explorer, but it also contains the contract metadata for everything that you've uploaded, so you can actually see details of the specific information in the contracts and use it like any other block explorer. Of course, though, we don't want to have a walled garden here where people can't actually make use of it if they don't want to sign up for an account. So you install the Epirus CLI, you create a project, and then you can use your standard Gradle or Java runners to actually run the project, or you can actually use Docker as well to do it. You obviously have to explicitly specify the endpoint you want to connect to, the keys you want to use, whereas if you're using the Epirus infrastructure, that's all configured via the portal. But again, the key thing here is that we don't want to restrict anyone here, so you can get the most out of all of this. But if you decide you want to do it without the actual Epirus portal, that's absolutely fine, and we want to support as many people as possible. So there you have it. We believe that we've really distilled down the actual developer funnel here for, when it comes to onboarding. Once someone, makes the logical choice of working with Ethereum, they no longer have all of these considerations. They simply need to install a CLI, create the actual application, and then run it. And it's as simple as that. We take care of all the other stuff behind the scenes, but then the actual projects that are being created are very high quality. And as I say, we're really thinking about, production grade stuff here. We're not thinking about casual developers. We're thinking about, teams who want to develop robust apps on the JVM. And so, we believe this is really compelling. So I encourage as many of you as possible to actually give it a go. So there again is the installation instructions. If you want to read a bit more about it, head to web3labs.com/Epirus, and there's links there to the documentation as well. I'd love to hear from as many of you as possible too. So if you do get working with it and want to have a chat, you can reach me via email, Conor@web3labs.com, or via Twitter @ConorS10.